Hey everybody, it's Mrs. C coming to you again with a transformation video, this time on reflections. So, is there an easy way to do a reflection? Well, yes and no. It depends on how many tricks you're willing to learn. When we did the translations, if you watch the translations video I just made, that was a pretty intuitive trick. You add or you subtract depending on whether you're going right or left or up and down. And that's pretty what I call intuitive. With reflections, maybe not intuitive. I don't know. You're going to have to make the call. So let's just go over the basics of what we already know about reflections, just talking specifically about the axes. So if we were to reflect this quadrilateral, this rectangle over the x-axis, I think most of us are going to be able to say, yes, a reflection over the x-axis would look about like that. Now, again, I'm not plotting the points. It's not perfect. We know that these would be the exact same shape and size. They just flip, right? It just flips over the x-axis. And so that was pretty easy, right? That was pretty intuitive, and that was just using the picture. So if I was to take this new image, let's call the original A, figure A. This is figure A prime. And let's say I wanted to flip A prime over the y-axis. Well, if I was to flip A prime over the y-axis, I would have A prime look something like that. A prime flipping over the y-axis becoming a double prime. These are just easy ways to acknowledge the figure and also how many transformations have been done. To go from the original A all the way to A double prime, it was two transformations, right? We flipped over the X, then we flipped over the Y. So that's what the little prime, one transformation, double prime, two transformations. I know you're wondering, is there a triple prime? Sure there is a triple prime if you were to do something else to it. Three transformations, triple prime. All right, so that's pretty much reflections in a nutshell, guys. And the question is there an easier way? And I said that's going to be kind of up to you. So let's take a look at what we can do. Okay, I brought you over to some example problems that you're going to be practicing this week. So the first question, what is the image of -6, -3 after a reflection over the y-axis? Now you see we're only reflecting a point, not a figure. And it's less work, but pretty much if you can do it with a point, again, you can do it with a figure, which is multiple points connected. So let's see, can we do it with a point? Poof, I've given you a nice little coordinate plane off to the side because I do want you to be able to see it in order to decide if there's an easier way to do it. So let's just plot -6, -3 for a minute. If I was to plot -6, -3, it would be about there, right? Oh, no, it would not be. It would be right about there, right? -6 meaning 6 to the left and 3 down. So -6, -3 would be there. And if I was to reflect it over the y-axis, that's this one, right? I'm going to jump over, and I'm going to be in the exact same position, but on the other side. So you tell me which value stayed the same. Did my x value stay the same, or did my y value stay the same? And it's pretty obviously, right? It's pretty obvious. The y value stayed the same. The y value was a -3 over here, and the y value was a -3 over here, meaning it was 3 down from the origin. The y value stayed the same. What changed was my x value. Originally, I was way over here at -6, and do you know what would have happened to get to the other side but be equally distant from the origin? It changed to a +6. And so the answer to my question after a reflection over the y-axis is it would be at 6, -3. So it would have the same y value, which was the -3, and the x value would have pretty much flipped, meaning going from the negative to the positive or positive to the negative. And so the final answer would be 6, -3. So let me write that, 6, -3. If we look over at the problem only, meaning don't look at the little graph. Remember I said if I'm flipping over the y-axis, my y value is going to stay the same. And if you think about it that way, it might be easy. Y-axis, y value stays the same. What changes is the x value becomes positive instead of negative. So can we actually apply that to the next question? Well, let's see. What do you think? If you were to, what is the image of 5, -7 after a reflection over the x-axis? Well, remember what I said in the other one? If it was the y-axis, the y value stays the same. So if it's the x-axis, you got it, the x value is going to stay the same. It's going to stay a 5. I could plot it to show you, and I'm going to after I get our answer. Do you remember what happened to the one that didn't stay the same? Exactly. You are so on it today. Let me just say, I'm so proud of you. It flipped to the opposite sign, right? So if it's a -7, you know it. It's going to go to a +7. So let's see if we can plot that out and just visually see what we kind of already know is going to happen. Give me 1 second. Okay, so here we are. I plotted our little 5, -7. You can see it. It's +5 on the x, right? So we're going to say that this is a 5 and this is -7. I think I did a pretty good job of my estimates there as far as graphing without grid lines, which is tricky. And we're supposed to be reflecting over the x-axis this time. And you know this baby is the x-axis, right? I'm kind of off my screen there. So if I was to reflect over the x-axis, I know you've done enough work to be able to say it's going to be way up there. Hope you caught me. I know those little dots are small. Yes, so which one stayed the same? Exactly, it was the x-axis that stayed the same, and it's the y this time that's changing and flipping. Remember, a reflection has to be equally distant from what we call the axis of symmetry. And if you are flipping over the axes themselves, the x and the y axis, then you need to be equally distant from the origin. And so what we find is if down here, right, we were 7 spaces from the origin. When we flip, we've still got to be 7 spaces. But since we're not down, we're up, it would be a +7 instead. And that just proves exactly what we said. This point right here, which is the final answer, is at 5 on the x and 7, which, by the way, is what we said the answer was. That's a lot of arrows. Let's go to the next one. All right, can we do it without the graph? I know we can do this. Can we do it? Yes, we can. If we're reflecting over the y-axis, remember, it's the y value that stays the same. And so that is going to stay a 6. And it's the other value that we flip to the opposite sign. But this time, Bella, shush, please. No, we're taping right now. 0 doesn't have a flip. 0 doesn't have an opposite, and so you will stay a 0. Let's try it on the next one. If you are reflecting over the x, it is your x that will stay the same. -6. And this time it is not a 0, it's a 4. So what is going to change? You are going to be the opposite, which would be -4. So our final answer will be -6, -4. That would be the reflection of the point -6, 4 over the x-axis. Okay, so if you thought it was over with those 2 simple rules, this is why I said, it depends on how many rules you want to remember. Those were pretty straightforward rules. Now we got another rule to deal with. So let's get set up for this one. Okay, so for the next one, I've actually put graph paper down because I was looking at it and I was thinking, you know what, I think you'd probably be easier if you could see it kind of happening. So with a problem like this, what is the image of negative 8, 2? After a reflection over the line, not the axis, over the line, y equals x, I can hear a community sigh of, like anticipation, because I know we get a little woozy sometimes when it's not reflecting over the axis, when it's reflecting over a line. And so that's okay. Just relax. It's not that bad. And so the problem is we don't have lines. We have axes. You've got your right here. Let's take a look at what do we have. We have green. Okay, it's green. No problem. We have that's not the y-axis. We have the x-axis and we have the y-axis. Those are always on our coordinate plane, right? But we don't have lines drawn unless we draw the lines. And so if we're going to reflect anything over a line, we would want to draw it. But I always tell my students, plot your point first. So we're going to do that. Let's plot negative 8, 2. I'm doing it 1, 2, 3, 4, 5, 6, 7, 8. That's negative 8. Positive 2 would be right there. So there's my negative 8, positive 2. And I'm supposed to be reflecting over the line. So let me give myself I'm going to try to hit this as best I can. Okay, there is the line y equals x. And just to remind everybody's going, how did you even know that, Mrs. C? Y equals x is in the form of y equals mx plus b. Except that in y equals x, my b is missing because it's 0 plus 0. And my m is not showing because it's assumed to be a 1. And that is how it goes. If there's no number but there's a letter, it's a 1 in front. And if there's no number or no letter, it's a 0. So my equation of a line, y equals 1x plus 0, is graphed this way, going through the origin and having a rise-run of 1 to 1. And so this is kind of old stuff, guys. We're supposed to remember that. So maybe go back over another video that goes over graphing if you're confused as to how I got that. So what we're supposed to do right now is we're supposed to reflect this point over this red line. And the question is, how do I do it? Well, it maybe is easy and it maybe isn't. You have to be equally distant from the line, just like we used to have to be equally distant from the origin. So you can go in any direction. Right now, I'm just going to see how far up is my green dot from the red line. Let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 up. And that means it would have to be 10 in this direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It would have to be 10 in that direction. You could do it either way. You could have asked, let me change color, because you're probably wondering, how did I know which way to go? Doesn't matter. I could have said how far over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you could reverse the other way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You'd still wind up in the same position. The question is, what is that position? Well, let's just look at our graph. We're at 2. And how far down? We can count 1, 2, 3, 4, 5, 6, 7, 8. Now I want you to make a comparison. The answer to the original problem and tell me what you see. I know it. You already saw it, right? You flip the numbers. You flip the y and the x and you put them in that backwards position. So instead of having negative 8, 2, you have 2, negative 8. Then you're asking, is it always that easy? Yes, it is. It is always that easy. So let's test it out. Okay, so here's another question. What is the image of negative 1, 7 after a reflection over the line y equals x? Well, you'll start to remember what the line y equals x looks like, not equals to. You'll start to remember it looks like this. And then you'll plot your point, right? I think I already have my point. Let's see if we can find negative 1, 7. Oh, I hope I go high enough. 1, 2, 3, 1, 2. So you can see what I'm doing. So so I'm not just like making it up. Sorry, I'm on the line. 1, 2, 3, 4, 5, 6, 7, and we are over there. There it is. Okay, so that's -1, +7, and I'm reflecting it over the line, and I'm wondering if I'm going to have enough room. Let's hope I do. Now, do you remember the trick? Because I have a feeling you're going to remember the trick pretty easily. You're supposed to flip-flop. That's exactly right. So the answer would be 7, -1. Let's see how we would do that. How do we plot 7, -1? 1, 2, 3, 4, 5, 6, 7, -1. There's where the point would be. And that is exactly the answer. So the answer right there would be 7, -1. And I know you're probably thinking to yourself, this does not look too horribly difficult to do. And you're totally right. It is not that horribly difficult to do. There's one other version, though. Okay, so if you were wondering how could it be any different, well, there it is. What is the image of 5, 8 after a reflection over the line y equals -x? So y equals -x, instead of being a positive slope of 1, is a negative slope of 1. And we've been down the graphing road before, so it's not horribly different. And there it goes. So that is y equals -x. So again, it's just a sloping line through the origin, a line that has a slope of a -1 instead of +1. And so I'm supposed to do exactly the same thing-ish. I would plot the original, which is 5, 8. So let's do that. 1, 2, 3, 4, 5. And then it would have been an up 8, right? 1, 2, 3, 4, 5, 6, 7, 8. And then I would plot that point right there. And so that point has been plotted at 5, 8. And so the question is, how would I actually plot this point reflected? Now, I think we can see it's supposed to be about that far, right? So it should be about that far over here somewhere. But exactly how far? And that becomes the question. So we don't want to, we don't want to approximate it. And again, you could do it the way I showed you by counting how many spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's just a lot of counting. And then reverse. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's exactly where it would be. That's just, I don't know, it seems like too much work. Because if you know the trick, you can actually get the answer right away. So one of these numbers stays the same-ish, and one of these numbers is going to change. And let's see if we can figure out what it is. 1, 2, 3, 4, 5, 6, 7. It should not be at 7. So I already realize I did some counting wrong. So let me go back and double check. 1, 2, 3, 4, 5. I did plot 5 right. 1, 2, 3, 4, 5, 6, 7, 8. I plotted 8 right. Did I count wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I didn't count anything wrong either. 1, 2, 3, 4, 5, 6, 7. Okay, guys, I figured it out. Now, I don't remember if I had to redraw it or... Yes, I did. I redrew it. So let's just recap. It was because the line was just a little bit off, and this line right here, let me see if I can point. Oh my gosh, that's awfully big. Hang on. All right, let's take that down. All right, this line was just a little bit off on its angle, and it wound up making the numbers be completely wrong. So if you were to count from here to here, it's 13. And if you were counting here to here, it's 13, placing our point at the appropriate place, which is at -8 and -5. So the answer would have been -8, -5. And now look at the original, which was +5, +8. So this one not only flipped them, meaning the x and the y values flipped, but we also had them both taking on negatives. And it's not always that they're both going to be negative. They're going to flip their sign. Whatever their sign was, it would be the opposite. And so this is actually a really good reason to show you why it's better to do it mathematically than to actually graph it, because little mistakes happen when you're graphing. The line gets a little bit out of place, you plot the point in the wrong place, and then it's just a big old hot mess. So stick with the math, it's usually your friend. So I have another example of a problem for us, but this one after that mess, I would like to try doing it without actually plotting it. And so let's see if we can remember. It says, what is the image of negative 8, 6 after a reflection over the line y equals negative x? Remember, this is the downward slope. This is the one we just did. So do you remember what we had to do? We had to flip-flop them, first of all, 6 and 8 instead of 8 and 6. But not only that, we had to change their signs. So the 6 was a positive, it becomes a negative, and the 8 was negative, it becomes a positive. And so the answer would have been negative 6, positive 8. That would be the correct answer. So, just a couple things. Let's see if we could just recap that. This is a much longer video than I wanted it to be, but it's a lot of information to get through. So let's just recap. Okay, so here's all our rules. Let's see if we can just throw it down for you so that you have some good notes. So if you're reflecting over the x-axis, remember the x stayed the same. And so if we were going to reflect 5, negative 2 over the x-axis, the x value would stay the same, 5, and you would just flip, meaning take the opposite of your y, which would be a positive 2. If you were going to reflect over the y-axis, your y would stay the same. So in this case, the negative 2 would stay, and it would be the x value that will flip or change, giving you a negative 5. If you're reflecting over y equals x, that was that positive line, y equals x, positive slope of 1. Remember, they flip-flopped, so the x went to the y went to the x. So it would be a negative 2, 5 in this case. And lastly, that last crazy one that we did, reflecting over y equals negative x, not only does it flip-flop them, and let's just do that, flip-flops them, but it also, what? Exactly, it changes their signs. So if it was a negative 2, it's a positive 2. If it was a positive 5, it's a negative 5. And that is what those would look like. So, okay, now you see what I meant by, yeah, there's tricks, but it depends on whether or not you find it helpful, whether you can remember the trick. Kind of depends on how much you practice, right? So head on over to that Delta Math and do some practice on reflections. These are the rules you're going to need to practice, and I promise you, the more you practice, the better you'll get. And don't forget to find me on the flip side.